This lecture is about finding the stability analysis of nonlinear system or differential equation. Now, what is the nonlinear differential equation? It is of the form dx by dt equals to ax plus by plus p of xy, where this p of xy will be the term which is depending on x as well as y variable. So this is called the nonlinear term. Similarly, the second equation will be of the form dy by dt equals to cx plus dy plus q of xy, where q of xy will be the term which will be consisting of x as well as y variable, and this is the nonlinear term. Now, in order to find, first we are going to find question number 1, find the stability of the system at critical points 0 and 2. Now the question is given that dx by dt equals to x multiplied by 3 minus 2x minus 2y. So we just multiply x with the inner terms. So it becomes 3x, and x multiplied by 2x will be minus 2x, and x multiplied by 2y will be minus 2xy. Similarly, the second system of equation, it is equals to dy by dt equals to y multiplied by 2 minus 2x minus y. So it will be equals to of the form dy 2y minus 2xy and minus y square. Now, how to find the solution of this? Suppose first step is to suppose that the first equation, it is equals to the function f of xy, and the second equation dy by dt, it is equals to the function d of xy. Now, what are these functions? What is the purpose of just substituting them as f of x and g of xy? We have to find the J matrix. J matrix is of the form that we have to take the partial derivative of first equation as with respect to x, and the partial derivative of first equation with respect to y. Similarly, in the J matrix, the second row will be equals to g of x, means that partial derivative of g function with respect to x and partial derivative of g function with respect to y at the critical point 0, 2. Now we are going to find them, the partial derivatives. So the first function of xy, it is equals to this, which is given in the question, and now we are going to take its partial derivative. So since we are taking the partial derivative with respect to x, so this term, first term will be equals to 3, and for 2x square, taking the derivative with respect to x, 2 becomes here, so it becomes 4x, and here y is constant, so we are going to get with respect to x, the derivative becomes minus 2y. Now we are going to substitute the values of x. X is 0 and y is 2. So we are going to substitute wherever is x, this is 0. So this term becomes 0. And wherever is y, we are going to substitute as it is equals to 2. So 2 into 2, it becomes 4. This term becomes 0. And this will be 3. So 3 minus 4 will be equals to minus 1. So this is the partial derivative with respect to x at critical point 0, 2. Now we are going to find the partial derivative of the function f with respect to y. So we can see that we are taking the partial derivative of y with respect to the partial derivative of f with respect to y. So this term becomes 0, this also becomes 0, and just this term becomes minus 2xy. Derivative of this term with respect to y, it becomes just minus 2x. So minus 2x is here, and when we substitute that x is 0, so all term becomes 0. Now we will see that g of xy, the function given is this. Now we will take the partial derivative first with respect to x. So this is not having any x, so it is termed as a constant. So the constant derivative is 0. So this term becomes 0, and this becomes minus 2xy with respect to x. So we get minus 2y, and this becomes 2y square. It is not having any x, so this becomes as a constant. So this term also becomes 0. So after that, we substitute the value of y. So y is 2. So 2 into 2, we get minus 4. After that, g of y also means we will take the derivative with respect to y. So this becomes 2. And the derivative of this second term, it becomes with respect to y we will take x as a constant. So y with respect to y becomes minus 2x, and the derivative of y square with respect to y, it becomes minus 2y. After that, just substitute the value of x is 0 and y is equals to 2. So this term becomes 0, this becomes 2, and this becomes 2, and y is 2. So 2 into 2 becomes 4. So 2 minus 4 will be minus 2. So after that, finding these terms, and we are going to substitute these values in the J matrix. So J matrix becomes minus 1, 0, minus 4, and minus 2. Now we are going to find the eigenvalues. How to find the eigenvalues? First, we must know that what is the characteristic equation. So in order to find the characteristic equation, we have to have this equation of the form lambda square minus trace of j lambda plus determinant of j. How to find the determinant of j? Just solve this as a determinant which is of order 2. So it becomes that we multiply minus 1 multiply minus 2. So this becomes 2, and the diagonal elements minus 4 multiplied by 0 becomes 0. So this becomes the answer of determinant of j becomes 2. And what is the trace of j? Trace of j is that we are going to find the sum of elements of the main diagonal. So what are the main diagonal elements? These two. So we will take its sum. So minus 1 plus, or minus 1 plus minus 2 will be minus 1 minus 2. It will be equals to minus 3. So this is called the trace of j. Now we are going to substitute these values, that minus trace of j minus minus becomes 3 lambda, and determinant of j value is 2. So substitute this here equals to 2 equals to 0. Lambda square is same. Now the characteristic equation is lambda square plus 3 lambda plus 2 equals to 0. Now we have to factorize them. Factorize means just we have to make the factors, and after making the factors, putting them equals to 0 separately. So we will get two eigenvalues, that lambda 1 is minus 2 and lambda 2 is minus 1. So these two eigenvalues, they are real and they are having same sign, but they are unequal, means, and we can see that both are less than 0. If both the eigenvalues or both the values of lambda are less than 0, then the system is said to be asymptotically stable. How to say that it is asymptotically stable? We have to learn the stability properties of linear system or differential equation. So these lambda values, if they are like this, that they are positive, the system will be unstable. If they are less than 0, then asymptotically stable. So all these we have to learn in order to find the stability of the system. After that, we are going to have the second question as that find the stability of the system at the critical point 0, 0. Now the function or the first differential equation, it is given as dx by dt equals to x minus 2y plus y square sine of x, and dy by dt equals to 2x minus 2y minus 3y cos of y square. How to find the solution of this? That first we are going to put that the first system of differential equation, it is equals to the function f of xy, and the second system of differential equation, it is equals to g of xy. In order to find its J matrix, we have to take the partial derivative of f with respect to x and y, and partial derivative of this function g with respect to x and y at the critical point 0, 0. Now finding this, we have to take their partial derivatives. So the partial derivative of the function f, it is equals to, and partial derivative of x with respect to x, it is equals to 1, but this becomes constant, so this will be 0. And now the partial derivative of this term with respect to x will be that this will be served as constant y square, but sine x derivative is cosine of x. And when we substitute the value that x is 0 and y is also 0, so this becomes 0, and cos of 0 is 1, but 1 multiplied by 0, it becomes 0. So 1 plus 0, the answer will be 1. Similarly, we will take the derivative now with respect to y of this function. So it will be that with respect to y, this becomes constant, so it is 0 term. Now this becomes minus 2y's derivative with respect to y. it will be minus 2. And the derivative of this function becomes that y square. Y square's derivative will be 2y. And sine x will be termed as a constant term. So we will write it as same as it is. So after that, just substitute the value that x is 0 and y is also 0. So x is 0 here, so sine 0 is 0 and y is also 0. So this whole term becomes 0 and the answer will be just minus 2. After that, we will find now the partial derivatives of this function with respect to x first. So partial derivative of this 2x becomes 2 and this becomes 0. This becomes also 0 because this is the function of just y. So y is termed as constant. So it becomes both the terms becomes 0. Now we have to find the function or the derivative with respect to y. So this becomes 0. This term is 0 here. Minus 2y's derivative with respect to y will be minus 2. Now this term is having we have to apply the product rule u into v because there are two terms y as well as cos y square. So in order to find the derivative of this, we will take that this is u and this is cos y square as v. So product rule we are going to use in order to find the derivatives. So this becomes first function same, or we can take the derivative of first function and the second function as it is. So the cos of y square is same, but the derivative of minus 3y will be minus 3. So it is like this plus, now the first function same and 3y. And what is the derivative of cos y square? Cos y square means that cos derivative is minus sine y square, but y square again we have to take its derivative, so it becomes 2y and minus minus becomes plus here. So this is the derivative by using the product rule of derivations or derivatives. So when we simplify them and substitute the value of x is 0 and y is also 0, so it becomes as that here is minus 2 same, but this terms becomes cos of 0. Cos 0 is 1. So 1 multiplied minus 3 will be minus 3. So we get here minus 3. But this term y is also 0, sine 0 is also 0. So all this term becomes 0. So the answer will be, and this also will be 0. And the answer will be minus 2 minus 3 will be equals to minus 5. Now we are going to substitute these values in the J matrix that f of x is 1, f of y is minus 2, g of x is 2, and g of y is minus 5. In order to find the eigenvalues, we will get the characteristic equation as lambda square minus trace of j lambda plus determinant of j, it is equals to 0. So when we substitute and find the value of determinant of j, so we have to solve this matrix. The matrix will be 1 minus 2, 2 minus 5. So this multiplied by 1 multiplied by minus 5 will be minus 5. And 2 multiplied by 2 will be minus become plus 4. So the answer will be minus 1. And how to find the trace of j? We just have to add these main diagonal elements. So 1 minus 5 will be minus 4. So this is the characteristic equation we get, that the value of trace of j is minus 4. So minus minus become plus 4 lambda, and the determinant of j's value is minus 1. After that, we have to factorize them, and we can find the factors by using the quadratic formula. Quadratic formula is minus b plus minus b square minus 4ac over 2a. After that, we have to see here a is 1, whatever the coefficient of lambda square, that is a. So a here is 1, b is the coefficient of lambda, so that is 4, and c is this constant term, so the constant term is minus 1. So now just substitute the values of a, b, and c in this equation, the quadratic formula. So it becomes b is 4, so it becomes minus 4, this becomes 16 plus 4 over 2. So just simplify them, and we get in the end the answer is minus 2 plus minus square root of 5. Now we can see that one value, eigenvalue is less than 0 and the other value is more than 0. So eigenvalues are real, they are unequal and have different signs. So if this is the case, that one is less than 0 and the other is more than 0, means one is negative and the other value is positive, then we are going to say that the system is unstable. And we can see this by using the table which we have already given in question number 1. So we have to look at that table in order to write down the final step of the answer, that the system is stable, unstable, or asymptotically stable.